Car engines work by internal combustion, a process that happens in each of the engine cylinders. Air and a drop of gasoline enter the cylinder. The piston moves upward, compressing the mixture. The spark plug ignites the gasoline, causing an explosion that drives the piston downward, powering the engine. Engine components are housed in what's called the engine block. It arrives at this plant partially made. Here they finish it off by machining the cylinder bores, the holes in which the pistons move up and down. The tool carves a crisscross pattern on the cylinder bore walls. Lubricating oil will cling to the grooves in this pattern, enabling the pistons to move smoothly. After machining, the engine block travels upside down to the engine assembly line. When it arrives there, a scanner records the block's traceability code, a barcode that enables the factory to track the block through every stage of production. As the engine block travels down the line, error-proofing devices ensure that each component is installed properly. Elsewhere in the factory, the crankshaft is slowly taking shape. The crankshaft is a bar that's rotated by the up and down motion of the pistons. As it turns, it transfers power to the transmission. The crankshaft starts out as a roughly shaped steel forging. Robotic arms pass it down the line from station to station until 20 tooling machines later, it's fully formed. Now they install a steel disc with teeth, called the reluctor ring. They heat it and press it onto the crankshaft. As it cools, it shrinks to a tight fit. This ring helps time the combustion cycle. As it spins, its teeth pass in front of a sensor, which reads the crankshaft's position and tells the engine to fire the spark plugs at precisely the right moment. Now they balance the crankshaft. If it's off kilter, the engine will vibrate. A computer analyzes the spin and determines whether they need to drill out metal at certain points to achieve equilibrium. Back on the engine assembly line, the engine blocks are still upside down. A robot lubricates the 4 bearings on which the crankshaft will turn. Then it drops the crankshaft into position. The pistons come next, 6 per engine, because these are 6-cylinder engines. The pistons are made of aluminum. Robots install them into the cylinder bores of the engine block. A steel connecting rod attaches each piston to the crankshaft. Now, workers can close up the back of the engine block. A robot applies sealant to the rear cover. They bolt it on manually with a tool called a multi-spindle torque gun. On another line, they assemble the 2 heads that'll cover the top of the engine block. This robot is applying sealant to spark plug tubes before inserting them into the heads. The heads cap off the cylinder bores. They provide each cylinder with a spark plug and 4 valves, 2 for allowing the fuel mixture in and 2 for releasing the exhaust. The black tubes running front to back are the camshafts, the components that open and close those valves. There are 4 per engine. A robot applies sealant and then bolts a cover onto the front of the engine block, the head, and a component called the timing chain. This chain connects the crankshaft to the camshafts so that they rotate in unison. This ensures the valves open when the pistons are in the right position. Finally, they spin the engine mechanically to make sure the components function properly.